So we've been recording the opening and closing. We're recording the closing ceremony. The opening ceremony was recorded. So was the panel and all the presentations as well. We'll be uploading everything once it's been organized and processed on our website, on the U of T Engineering website. And you'll get an email with a follow-up once that's all been done.
Okay, we'll get started right now. So hello everyone, good afternoon. I'm Safwan Hussain, I'm one of the co-chairs of UnERD 2020. I'm joined by Maisha Biswas, who is the other co-chair. I hope you all enjoyed what UnERD 2020 had to offer. Thank you all for building engineering research connections for a vibrant and innovative society and celebrating resilience in research with us today.
I would like to introduce Professor Deepa Kundur, Chair of the Department of Electrical and Computer Engineering. This year, we are fortunate to be sponsored by the ECE department, and the prizes for the data analytics and AI categories are funded by them this year. Professor Kundur is an author of over 200 journal and conference papers. She is also a recognized authority on cybersecurity issues and has appeared as an expert in popular television, radio, and print media. She is a fellow of the IEEE, a fellow of the Canadian Academy of Engineering, and a senior fellow of Massey College. Please welcome Professor Deepa Kundur. Professor Kundur, will you be using slides?
Yes, I will. And so I will share. I will share.
Okay. Oh. Hi, Professor Kundur.
Yeah, I'm here. So
Okay.
You can see it, right?
Yes.
Okay, fantastic. Well, thank you very much for the introduction. As was mentioned, my name is Deepa Kundur. I'm professor and chair of the Department of Electrical and Computer Engineering. And it gives me great pleasure to talk about some things that I'm really passionate about, engineering and research, and especially careers. And so I was given some flexibility in what this talk should be. So I thought I'd take an opportunity to try and see how we can link all of them, careers, engineering, research, to help you as you move forward in your career path, decide what avenues you may want to pursue. What really brings us all together is, engineering. And as we all know, and we've experienced over this summer, it's a branch of science and technology concerned with design, build, use of engines and machines and structures. And it's also the application of math and science to solve societal problems. Now, we're seeing a shift in engineering. In engineering, we're essentially aiming to solve some of the biggest global challenges. And so, in my own research personally, it's been very rewarding because I've looked at a variety of things from an electrical and computer engineering perspective and seen how we can do things like make the world more sustainable. How can we create smart cities? How can we cyber secure infrastructure? And more recently, I'm looking at data analytics for medical and healthcare systems, psychiatry. So that's basically engineering. There's a lot we can do and a lot that society needs us to do. But then there's also research, and engineering really lends itself well to research. Research, as you have all experienced in a very experiential way this summer, is about doing something original, doing something people have not done before, creating, producing new knowledge. So these could be things like novel mathematical results, simulation, design, observation of experiments. It also helps you because you're at the cutting edge, influence technology development, and also lead research teams and disseminate research, and you need to write grants. Research really is a path and it's a career. And so I've been able to have a wonderful opportunity to bridge my loves in research. And I'm hoping many of you have identified some things you really enjoy this summer and also identified things you don't enjoy. So I have basically worked at the interface of signal processing, which really is, the foundation of AI today, cybersecurity, and also mathematical modeling and dynamical systems. So my work has ranged from image enhancement, data fusion, security for copyright protection, digital rights management, data hiding, securing critical infrastructure such as the power grid, surveillance systems, and much more. And so what I love about research is that you can really have an impact in different ways. So of course there's the work you do, the way you advance science and technology, but you can also help the local ecosystem. And another thing I'm really passionate about is our burgeoning entrepreneurial ecosystem in the Greater Toronto Area. And one part of that is this Canadian AI ecosystem that we're really leading. And so part of the research I do, especially looking at AI and data analytics, really helps to create talent as well as intellectual property for a lot of startups. So some of my research works with big companies, utilities to help cyber secure our critical infrastructure, and other components is very, just pure research oriented, and other components work closely with startups. So we talked about engineering and research, but you're all here because you are on your way to developing a career. So what is a career? It means many different things to many different kinds of people, but I like to think of it as a path. Okay, and it's not necessarily a linear path. And some of the most exciting, amazing careers are not linear. So they take twists and turns, and it seems like at certain points you take a step back, but hindsight is 20/20. And a lot of times those steps you think you took back really helped you move forward in other ways later on. So there's elements of your career where you kind of strategically decide what you want to do. So you all decided to come to U of T engineering. That was a big thing. You will all decide, maybe given the opportunities you have, where you want to go. But a career is also exciting because opportunities often come to you. Sometimes you don't have choice, doors close, and so it's the culminating effect of being both proactive and planning, as well as being reactive and seeing where life takes you, that makes for a very interesting career. Now, a career is very different than a job. And a lot of people are, the end result, they just want to make sure they get a job. And this is completely understandable because a job really helps sustain you. But a job is different, really, than a career. And I'm hoping that many of you are looking at a career. A job is task-oriented. It's short-term. Many jobs come together and are part of a career. And it's usually something that's very distinct and separate from other aspects of your life. A career, and especially if you decide to go into research, touches all aspects of your life. It could spill over into your personal life. You have a lot of autonomy. So the hours are often not set. This provides great flexibility, but if you're really passionate about what you do, you really have to learn to manage it because it can really expand. It's also very much a chosen pursuit, and it's long-term and built over a lifetime. So one thing that is about research is it's something that has to be built over the course of many careers. A research program, research thrusts require collaboration from a variety of people over time. And so careers and research go hand in hand. It's hard to get a job in research. It's more of a career. And a successful career, and that's what often people are looking forward to, and I'm hoping the experience you've had this summer helps you in that, is having your trajectory, your path align with your goals. And the thing is, I know when you're younger and you're still, at the beginning of your career, you're trying to figure out, what does it mean to have a successful career? And you talk to a variety of people, and especially your generation with social networking, you have access to a lot of different information and people's opinions. But one thing I'd like you to do is take a step back and reflect on the experience you've had this summer and figure out what success means to you. And it's completely fine if success means different things to different people. I'll show you two different versions of success. And this is a beautiful poem that I love. It's What is Success by Ralph Waldo Emerson. And he says it's to laugh often and much, to win the respect of intelligent people and the affection of children, to earn the appreciation of honest critics and endure the betrayal of false friends, to appreciate beauty, to find the best in others, and to leave the world a bit better, whether by a healthy child, a garden patch, or a redeemed social condition. And so this is a very holistic perspective, and it's completely fine if this is what you would want to adopt or it influences your version of success. There's also other versions of success, right? Like the American dream, right? Which we are influenced very strongly in Canada. And this is really about opportunity, hard work, free choice, and it's often equated to material prosperity and opportunities for education. And so this is another perspective as well, which is also valid. And so at this stage in your career, it's often good to see what success means to you. But you and your goals really establish what your career is. And so I like to talk to people because they're often trying to figure out what to do. And remember, it's important to understand that no one decision defines your career. You and your career are both a work in progress, okay? And so it's not just about your career, it's not just about you. You work together to establish a career. You have significant control over who you are and what you do. Okay, so that's one part of aligning your goals with your career. And you do have some control over your career, but sometimes you can't control things. For example, COVID, we could not control that. And so we have to be adaptable, but there's some things we can control. So it's a partial control kind of situation. And when you're looking at formulating a career trajectory that aligns with your goals, one strategy is to modify yourself to meet your career goals. So the decisions you make, the education you get, the skills you adopt, the attitudes you adopt, you can change to align to the kind of career you want. A second strategy is to modify your goals to suit who you are, because we're often innate and have innate strengths. And so it's really the coming together of both of them that helps you align your goals. For research, it's about developing critical thinking, scientific curiosity, and also I think many of you have learned the need for patience. And the second strategy really is, you can also adapt your career goals. There's many, many ways to have a research career. The classical one is academia. I mean, you're in it right now. You're seeing professors. You've worked in a lab. There's different kinds of research lab, not for profit, in industry, government, and there's also startups. Startups need research. It's critical to the functioning and growth of society. So it helps to have your research career goals aligned with your interests, your strengths, and also the existence of a critical mass of supporters, so your network. And so, you started to form a network in undergrad. You've started to form that network further in this experience over the summer. So really looking at all of those, I would say, is about what they say, finding your passion. Okay, so it's coming together of interests and strengths. And one thing you may want to consider, especially if you're interested in a research career, and I saw this earlier on that board, that beautiful board everyone was contributing to. If you're interested in a research career, and it's a very flexible career, and it enables you to find your passion, consider going to grad school. And so what is a grad degree? Okay, so we have 3 at U of T. Okay, and it's similar in a lot of different schools. We have two master's programs, Masters of Engineering, which can be done part-time. It's considered to be a terminal degree. It's more of a professional degree. You want to learn more about what you did in undergrad, specialize a little bit, but then you often go to the professional world. And then we have the other 2, the Masters of Applied Science and the PhD, which are research-based. And so there you have in-depth knowledge through some courses, and you do a thesis in those 2 degrees. And this involves producing original research. So it's basically what you've been exposed to, but you have much more autonomy in defining your problem, and it is really quite a bit more in depth. And there's a lot of reasons really to consider doing grad studies, but there's good reasons and bad reasons. So if you're trying to figure out, should I do grad studies? These are the good reasons. It's an opportunity to invest in your future. Join a research organization at the end of it. Get noticed in today's job market. Make connections. Develop yourself personally. Increase financial prospects. Pursue your interests in more depth. Get academic recognition. So there's a variety of them. And there are some not so good reasons that I would suggest that you maybe consider other options. So bad reasons to go into grad school is just to avoid a job hunt, or to avoid personal or financial obligations. You want to push your school loans further down the road. You don't know what to do with your life, so it's just sort of, you kind of pick it. You're dissatisfied with your current employment, but you wouldn't mind learning more about a subject. But as you have experienced with the research, it really is something that's very time consuming, and you have to be dedicated to. So you really need to go for those good reasons rather than those bad reasons. Now, it's very natural to sometimes feel you came out of a research experience and I don't know what I learned. And that's very natural because what a research experience often does, in contrast to course-based education, is it changes you, it gives you character. And so so a lot of those competencies you've achieved are very transferable, and you have to realize that. So it ideally helps with garnering a more questioning, inquiring attitude, self-confidence, problem-solving skills, ability to make an impact, ability to learn quickly. We are in a knowledge-based and learning economy. The skills you learn in a research experience, as well as in grad school, are invaluable in a variety of contexts. And depending on the degree program you choose, the intensity of these transferable competencies change. So a PhD gives you those ultimate experiences. And it helps you to be able to have the capability to handle a high-paced, knowledge-based economy. So if you're curious, where should I do grad studies? Okay, well, how do you make that decision? A lot of people look at the existence of a desired supervisor because, as you have experienced, the people you work with are very important in defining and characterizing the experience and success you have in research. You would want to go somewhere where there's a critical mass in your field of interest and desired courses and opportunities. And also, of course, reputation, location, support network, and ultimately it's about, does it feel right? Go and explore it. Try and get an idea of the culture of an organization. For me personally, I did all my degrees at U of T. I simply love the culture at U of T. Next, you may want to know, well, how do I select a research supervisor? So you've had an opportunity to have some experience, albeit I think COVID unfortunately interfered with the situation. But the way you would pick a research supervisor is based on your area of interest, if it's a personality match. A lot of my students, for example, come to me because they like working together and the dynamics between us, the research and supervision style, the scale of the research group. So really, different professors are at different stages of their careers. Some are younger, have small groups, and can give one-on-one attention. Others have large groups, like myself, could be administrators. There's different advantages to each kind of group. With larger groups, there's an ecosystem, a lot of interesting opportunities. And the mentorship occurs in a more distributed way. If you like the one-on-one supervision style, a smaller group might be better for you. And then look at the placement of former students. Like in my group, for example, many people go and become academics, professors. It's very difficult to do, but we do have a very nice ecosystem where there are opportunities for them to shine and develop into becoming professors. And then also the expectations. You don't want to join, for example, in an experimental group where it's expected you'll be there for so many years and that was not your understanding or expectation. And talk to other students, but be discriminating. Remember, not all opinions would necessarily reflect on your own experience, and some definitely would. But it was a personal decision on my part, and a very intentional decision to go to grad studies. And I'll give you an idea of why I went. I loved school and learning. I wanted more time to reflect than undergraduate studies allowed. I wanted to take a step back, and it is very much like that. And I enjoyed that quiet, so I could explore things and be a bit more self-directed. I loved my profs, and I wanted to get to know them better. And you get to know not just your supervisor, but other professors, because there's opportunities to give research presentations, TA for a variety of courses, which brings to the fact that I really wanted to be a TA. I enjoyed that environment and get to know my own TAs better who are in grad studies. And I really liked Toronto, so I decided to stay here. I lived in Mississauga during undergrad, so it was an opportunity for me to move downtown and to explore more. So I'll conclude by saying, don't worry. I know there's a lot of decisions, and you may be stressed, am I making the right decision? As someone, who is, so I graduated in '93, so I've got many, many more years of experience over you, but I will tell you what I know, that there are many paths to success. And if you choose one direction now, it will not necessarily be set in stone. There's many directions and ways to achieve what you want. And so I think it's about having an attitude where you make the best of a variety of situations. It's completely fine to change your mind and change your direction. And often what you have learned would be very helpful even if you change directions. And finally, remember one thing. Okay, there's success, and I know everyone's trying to be successful today, but there's also happiness. And the two are not necessarily the same. And understand this, as we talked about, success means many, many things and could be different for different people. But I like this quote by Dale Carnegie: success is getting what you want. Happiness is wanting what you get. And I think really life is about balancing the two and seeing both success and happiness jointly in that way. Thank you very much.
Thank you, Professor Kandor.
Our next speaker is Professor Thomas Coyle. Professor Coyle is the Vice Dean Undergraduate and Associate Professor in the Department of Material Science and Engineering and an Associate Director at the Center for Advanced Coating Technologies. He has also been serving as the Vice Dean of Undergraduate Studies in the faculty since 2015. His research focuses on advanced ceramic composites, coatings, powder processing, and the design and characterization of multi-phase microstructures. Please welcome Professor Coyle.
Thank you. I'm not sure where you found that picture. I've been working for years to get that one out of circulation, but thank you for the kind introduction. I'll share my screen and see if we can get started. Okay, does that look correct?
Yes, we can see everything.
Okay, great. So I thought I would take a bit more of a personal look at this, and perhaps we can compare what will essentially be my path from my first research experience, which was after the summer after my third year as an undergrad, up to the point we are today, which actually is about 30 years after I joined the university. I find it difficult to believe it's been that long because it's been a wonderful time and has passed very, very quickly. So my path from third year to today is not very far in terms of distance. I did my undergraduate studies at a small university in Western New York, a very rural area. It's only about 100 kilometers from Toronto as the crow flies. As I said, it's very rural. The closest cities are Buffalo and Rochester, and those are both over 2 hours drive away. My undergraduate program was actually in something called the New York State College of Ceramics at Alfred University, which is a state-supported private college, or we might call it a faculty here in Canada, embedded in a small liberal arts college. And so when I say small, the entire university had approximately 2,500 undergraduates. It's a beautiful area, as you can see. I spent my first 2 years in residence right here. So the summer after my third year, I got a job at a little multi-layer ceramic capacitor manufacturing operation in the town of Olean. As my first opportunity to really spend some time doing research. What I did that summer was to work on a project that looked at the effect of minor variations in the chemical composition of the ceramic electrode, which is the insulating layer separating the the electrodes in these multi-layer capacitors. So these little devices are ubiquitous on circuit boards. If you've taken a computer apart and looked at any of the boards inside, you'll see lots of these little shoebox-shaped components. They range from 1 to 2 millimeters thick, maybe 3 to 5 or 6 millimeters in length, which means the little ceramic dielectric layers are on the order of 5 to 20 microns thick. So it was, particularly at that point in time, a pretty high-tech operation, and I certainly enjoyed that summer and learned an incredible amount. Went back to university in the fall and was faced with the choice of a fourth-year thesis project. Because of the supervisor that I wanted to work with, ended up with a thesis in quite a different area of ceramic technology, much larger scale operations. So we were investigating the properties of a ceramic refractory material. In this particular case, it was a new material developed to avoid corrosion under high temperature conditions. And so these are the materials that line industrial furnaces, high temperature chemical equipment, and the scale of these components is more like 2 to 3 meters in diameter, with the refractory layers being 10 or 20 centimeters thick, so completely different scale of operation. One of the interesting things about this particular project was the opportunity to spend the month of January with the company that was supporting this work. The company was located in Worcester, Massachusetts, and was a very large, very old, with a long history, ceramic manufacturing company. As you can see here, world's largest manufacturer of abrasives. So, you know, sandpaper and other sorts of industrial abrasives, as well as these refractories that I was working on. So we spent the month of January there. Again, completely different experience than the one during the summer, but equally interesting, with, again, a tremendous amount of learning, both about technology and about my interests. So by the end of fourth year, completed the thesis, managed to graduate, and because I had found so much enjoyment in those two research opportunities, I knew that I wanted to go to graduate school. I was absolutely certain. I actually visited several universities and talked with professors and graduate students, and found that the opportunity that interested me the most was at MIT. As you can imagine, this was a huge change for me, coming from an undergraduate program in the middle of basically nowhere with 2,500 students, to MIT in the middle of Boston, with its incredible reputation, and I don't even know what the enrollment is, but it's substantially bigger than Alfred University. So before I even mention what I did in graduate school, I think I need to set the scene a little bit, because we're talking about the mid to late 80s. And if you can believe it, at that point in time, ceramic materials were the talk of the town, so to speak. In Japan, they were even describing it as a ceramic fever, with companies and investors sort of falling all over themselves to get involved in the development of new and advanced ceramic materials, because there was a new recognition of the potential for these materials to make really quite substantial contributions across a range of industries. And so I really arrived in graduate school at a peak of interest in this particular sub-discipline of materials engineering. And the project that I found myself working on was a project looking at increasing the fracture resistance of ceramic materials. As you know, if you drop most ceramics on the floor, they break, which is a problem. There were theories and development work underway to improve that property and thereby make these materials more widely applicable. And without getting too far into the details, what my work in graduate school focused on was a newly discovered mechanism for improving the resistance to crack growth, known as transformation toughening, that involved some very interesting thermodynamics and kinetics occurring around the tip of a propagating crack. So that work led me to network with several other graduate students and make the acquaintance of professors at other universities who collaborated with my supervisor. About halfway through my graduate studies, there was a bit of a hiccup in the road. My research supervisor left MIT and moved to Berkeley, which left me with some decisions to make. And in this particular case, opportunity created a new doorway that I decided would be something I should pursue. And so the opportunity to work at the Naval Research Laboratory in Washington, D.C. arose. They were involved in some very similar research work, and in fact, we had collaborated with them over the previous year. And so I actually completed my graduate studies working as a full-time ceramic engineer at the Naval Research Lab in Washington, D.C. As time went on, the development of this transformation toughened zirconia has led to some really interesting new products. Some of them are shown here. I have a couple of these upstairs in the kitchen, ceramic knives. More recent development are zirconia crowns and bridges, now of growing application in dentistry, and then quite a wide variety of other types of industrial components. So that was a very interesting topic, still dear to my heart, and I find it difficult to leave that behind without spending another 20 or 30 minutes talking about all the interesting details about that. But eventually I did graduate. I did finish my doctorate. And wanted to expand my experience. And as luck would have it, again, opportunity opened a doorway that I decided to walk through. While I was at the Naval Research Lab, we had a visiting researcher from UnERD, which is an aerospace research center in France. And when I finished my degree and he returned to France, he invited me to come and spend a year working with him in his laboratory. And so I did that, spent a year living in Paris, commuting to the suburbs where the research center was located, and began to work in a closely related but different area of ceramic matrix composites. Again, the idea was the same. How do we improve the fracture resistance of these brittle materials? Following that, I came back to the U.S., back to the Washington area, and spent another year and a half as a postdoc at the National Institute of Standards and Technology, continuing to work in the general area of ceramic composites. And then another unexpected opportunity arose. Again, the French researcher who I had met 2 or 3 years earlier now was visiting for a conference, indicated that his alma mater was looking for someone to spend a year helping them establish a ceramic research laboratory at his undergraduate university, which was one of the écoles supérieures in the French system. And so again, I took the opportunity to expand my experience and spent a year at this institute, which is located in the beautiful city of Nantes at the mouth of the Loire River. Again, wasn't all that it could have been. Some of the funding for the establishment of this research laboratory fell through, after I had arrived in France. And so in many respects, from a technical and career advancement perspective, you might consider this a bit of a bump in the road. However, it was in terms of that other definition of success that Professor Kunder spoke about, it certainly contributed to the development of my life and that of my family. So about this time, I decided that maybe I should be looking for a real job, and so the opening at the University of Toronto came up. I applied for it and was fortunate enough to be hired as an assistant professor in the Department of Material Science and Engineering. And so I arrived at Toronto. So although it was only about 100 kilometers from Alfred to Toronto, the path that I actually took to get from Alfred to Toronto was a much longer and really much more interesting path. So now that I've been at the University of Toronto for 30 years, I can look back at those experiences that you are just beginning to encounter, and just have been trying to imagine what it would be like to start on that path again, and in many ways envy the opportunities that you have ahead of you. So that was all about me, and as much as I may find that interesting, I thought you might like to hear a little bit about some of my classmates in that third year at that little university in Western New York State. So Craig, who was my partner in that fourth year research project, went on to do a master's degree at the University of Illinois, after which he joined what was at the time a large industrial research laboratory, the U.S. Steel Central Research Laboratory in Pittsburgh. Unfortunately, the steel industry in North America had a very difficult time from the mid 80s on, and U.S. Steel was forced to downsize their research operation, and my friend was a casualty of that downsizing. He fairly quickly obtained a new position at an AC Delco research facility in Detroit. This is a company that, among other things, you might know of as being a manufacturer of spark plugs. He wasn't particularly fond of the Detroit area, and when an opportunity arose at the Norton, a new Norton company back in Worcester, Massachusetts, where we spent that January several years previously, he obtained a position working for a new joint operation, Norton and Saint-Gobain, a French company, known as Norton Saint-Gobain Advanced Ceramics. And he had a very successful period at that manufacturer. He became involved in the design and manufacturing of solid-state igniters for gas ovens and barbecues, which replaced the previous technology, which was a continuously burning pilot light flame. And so not only was it much safer, it saved gas, and he has a number of patents in that area. Since that time, he's moved on to a couple of other smaller companies competing with Norton Saint-Gobain in this area of ceramic igniters, and most recently has returned to Massachusetts and joined a company known as the Ceranova Corporation. And I'll come back to that as if you're looking ahead, you'll see at the lower right-hand side of the slide. Another good friend of mine from my undergraduate time was a fellow by the name of Sam. So Sam found the undergraduate studies a little more difficult than some of his classmates, and in fact ended up taking a year off, both because of family challenges and a need to, well, how should we say this, refocus on his academics. But he did finish his bachelor's, quite quickly found a position as a plant engineer working for Corning Incorporated in Corning, New York, and worked there for, I don't know, 3-4 years. And then he and his wife both found opportunities in Ohio, which is where his wife's family was from. And so Sam began to work for a General Electric subsidiary known as GE Super Abrasives, a company that was just beginning to commercialize the use of artificial diamonds as abrasives. And he has spent the rest of his career in that area, in some cases working for, as you see, for 2 or 3 different companies, all in the same place, and that's because the company has been purchased several times by other corporations. So although he's worked for several companies, for most of that time he's actually been in the same building. Kathy was 1 year ahead of me at Alfred University. After leaving Alfred, she chose to do graduate studies at University of California, Berkeley. As a graduate student there, she also worked in the fracture resistance of ceramic materials, and our paths frequently crossed at conferences. And her supervisor at Berkeley, my supervisor at MIT, collaborated a fair bit. And eventually my supervisor, as I mentioned, ended up moving to Berkeley. After completing her degree, she became a professor at Northwestern University. And after establishing herself as one of the leading researchers in our field, was elected as president of the American Ceramic Society. This is, the largest worldwide technical society for this particular discipline, and presided over a society with a global reach. And most recently, she's moved to California as a professor at the California Institute of Technology. And the last example I want to give you is Mark. He was a classmate of mine at Alfred, He also went to MIT to do graduate work, obtaining a PhD about the same time as mine. He and some of his classmates and other members of his research group at MIT launched a startup immediately after graduating from MIT. That company, Serenova, has been successful now for over 25 years, working in a variety of ceramic processing areas, primarily working as a defense and space contractor. And just to close this little circle, as you see, Craig has eventually joined Mark at Serenova in Massachusetts. So there's a bit of a personal trip down memory lane for me, perhaps giving you a bit of an idea of what that path looks like for a few individuals. And so I'm going to toss the question out to you. Where do you see yourself going, having had a summer of experience with research? Where do you see your path leading? Are you interested in continuing to work as a researcher? Or do you find research really isn't for you? And perhaps you'd rather follow the route that my friend Sam took, which was to get out into the working world and establish yourself in his case in manufacturing. So again, just sort of looking back, what do I see as characteristics of individuals who seem to fit well with a research-oriented career? I think you need to be curious. You need to be open-minded. You need to be persistent because things don't always go as you'd expect them to. And along with that persistence is flexibility. And as you perhaps saw from the stories that I was describing to you, you need to be collaborative. Networking and the personal contacts you make may, in the future, lead to unforeseen and very interesting opportunities. So I'm going to close there. Thank you very much. And I don't know if we have time to do any question and answer, but I'd be certainly happy to answer any questions if you have them.
Thank you, Professor Coyle, for sharing with us your amazing career path. I thought it was very insightful.
We have come to the point where we've all been waiting for, recognizing our exceptional researchers for their presentations today. Everybody will receive a participation certificate, and the winners will receive an additional certificate. Additionally, all presenter certificates will be published in the STEM Fellowship Journal. More details about the process will follow today. All winners will also receive an Accreditable badge, which will be sent to their LinkedIn account, which they can include in their profile to showcase their achievement. Here's the awards layout. First, we will present the outstanding podium and poster presentations in their respective categories. Then, we will present the best abstract, best podium, and best poster presentations. Finally, we will award the top researcher title. I would like to invite Professor Coyle to present the researchers today. Professor Coyle, I think we sent you some speaker notes, and they refer to the slides as well as some of the text that you would be saying. Were you able to access this?
I have them in front of me.
Okay, great. So this would be slide 5, outstanding presentation categories.
Okay, so we'll begin with our outstanding podium and poster presentations in their respective categories. Each of these students will receive a credible badge to showcase on LinkedIn and a $100 cash prize. After we announce the names of each winner, oh, that's just for me to do. Sorry.
Yes, as a
Great.
team,
Okay.
After we announce the names of each winner, just a pause. Thank you.
Okay, bioengineering. This award is sponsored by the Department of Chemical Engineering. And the bioengineering top podium winner is?
It should be on the notes. Maybe if we refresh.
Yeah, okay. I'm impressed that you were able to insert these into the notes as we speak.
We have a hard
So anyway, bioengineering top podium winner, Raymond Hawkins, for his presentation, adherence junctions and integrins cooperate during, oh boy, Drosophila embryonic wound closure. And the bioengineering top poster winner, Spencer Zhao, for his poster, an in vitro hydrogel scaffold co-culture of, and I'm going to mangle this one, lymphangioliomatosis, LAM cells, with immune cells for improved LAM disease modeling. Congratulations. The next area is human health, and the winners are Human Health Top Podium Award to Lauren Derland for her presentation, Functional Maturation of Human Pluripotent Stem Cell Derived Cardiomyocytes in 3D tissue constructs using chemically defined maturation media. And the Human Health Top Poster Award winner is Kevin Zhu for his poster, Designing an Affordable, Easy-to-Use EEG for Measuring Student Engagement in Learning Environments. Congratulations. And the next area, environment and materials. And the winners are Environment and Materials Top Podium winner, Marlon Palmer, for his presentation, Statistical Inference on the Effect of Additives on Neutral pH Polymer Electrolytes. And the Environment and Materials Top Poster Award winner, Anthony Osguler, for his poster, Investigating the Catalytic Performance of Supported Vanadium Oxide Catalysts in the Partial Oxidation of Methanol. Congratulations. The next area, data analytics and artificial intelligence. These awards are sponsored by the Department of Electrical and Computer Engineering. And the winners are the Data Analytics and Artificial Intelligence Top Podium Award winner is Amy Chen for her presentation, Detecting COVID-19 in Chest X-rays using transfer learning. And the award winner in Data Analytics and Artificial Intelligence and Robotics and Mechatronics, top poster winner is Cheng Li for his poster EEG and Body Posture-Based Multimodal Emotion Recognition. And continuing with robotics and mechatronics, the top Podium Award winner is Dana Kokoska for her presentation, Leaky Wave Apertures for Satellite Applications. And I should mention, this award is sponsored by the Department of Mechanical and Industrial Engineering. Congratulations, Dana.
Were you able to hear that, by the way?
I haven't heard the applause for the last couple of awards.
Okay, I think it's an error. That's okay. Or maybe...
There we go.
Okay, great.
And in the engineering education category, the winners are the top Podium Award winner, Julianne Attai, for her presentation, Best Practices for Effective Teamwork in Online First-Year Design Courses. And the top poster award winner is Angelina Liang for her poster, Development of Longitudinal Tracking Methodologies to Assess the Long-Term Impact of the Discovery STEM Educational Initiative. Congratulations. And now we move on to the Best of UnERD Awards. These students will all receive an accreditable badge to showcase on their LinkedIn, a $200 cash prize, and access to STEM Fellowships, Scientific Publishing and Communication Consulting Service. Students will be paired with STEM Fellowships graduate level consultants from among the Canadian U15 universities, and through one-on-one review and mentorship, the consultants can help the researchers to improve their writing, develop high impact, even higher impact presentations, and to become strong scientific communicators. So the best abstract, Aaron Zhao, for his abstract on extracting key features from EEG signals to classify the attention levels of students. The best poster presentation award winner, Subaita Raman, for her presentation, Validation of an Image Analysis Algorithm for 3D Hydrogel Culture Platform Glance. Congratulations. And the Best Poster Presentation Award winner is Bipasha Goyal for her poster, Affinity Controlled Release of Rod-Derived Cone Viability Factor from an Injectable Hydrogel Drug Delivery Vehicle. Congratulations. And finally, the Top Researcher Award from amongst the Best of UnERD winners has been chosen to have their paper, their full paper published in the STEM Fellowship Journal. And so the Top Researcher Award goes to Subaita Raman for her work on the validation of an image analysis algorithm for 3D hydrogel culture for the 3D hydroculture platform Glance. Congratulations again, Zubeta.
Thank you, Professor Coyle. Congratulations to all of our award recipients and everyone for their outstanding presentations. On behalf of the UnERD 2020 Planning Committee, we would like to thank everyone who made this day possible through their engagement.
We would first and foremost like to thank the Vice Dean Undergraduate Office for their over decade-long continued commitment in the delivery of the Undergraduate Engineering Research Day. Thank you also to our sponsors, the Edward S. Rogers Senior Department of Electrical and Computer Engineering, the Department of Mechanical and Industrial Engineering, the Department of Chemical Engineering, and STEM Fellowship for their contributions to UnERD 2020.
Thank you to our keynote speakers, Dean Eep, Professor Kilkenny, Professor Kondor, and Professor Coyle for sharing your insights with participants today. We extend our thanks to judges who are lending their expertise and time, and researchers who have persevered around the world to explore boundless ideas for a better future.
The virtual nature of the conference, while seeming restricting, has opened a world of possibilities for designing student engagement by our team. We tried our best to make the inaugural online UnERD the best it could be, and we hope you enjoyed it. As co-chairs, we are so lucky to have such a creative and diverse team. We hope this showed in the programming. We will leave the networking channels up and encourage you to take a look and answer a few prompts to reflect on your experience during UnERD 2020. We want to help other undergraduate students learn more about research and how they can participate. Thank you all for being here. It is our privilege to bring this prestigious conference to you. Have a great remainder of your day. Bye.
Thank you, everyone. Goodbye.